So 9.4 part 2, we're going to look at ellipses. And the first thing I always do is I'll give you guys the definition, then I'll show you a picture that I think most people will understand the definition better. We'll go through some of the terms and then examples. So, definition of an ellipse. First of all, it's a collection of points in the plane, meaning it's a two-dimensional shape. Such that if you measure the distance from one special point in the ellipse to the edge, and another special point in the ellipse to the edge, and you add those distances up, they come out the same. So there's two special points inside of an ellipse. I'll tell you what they're called in a minute. And if you measure the distance from those 2 points to some point on the edge of the ellipse, add those distances up, it will always come out the same. Okay, and I'll bring up a picture next so you can see kind of what I'm talking about. So first of all, you have to have two special fixed points in the ellipse. In this picture, you probably can't see it that well, but it's point B and point C. Those are the two special points. Point E is a point that I can drag. I think I gotta go back to the computer. But it's a point that I can drag anywhere around the edge of the ellipse. And as I do it, I'm going to continually measure the distance from E to B, which is that line segment I just clicked, and E to C. I'm going to continually measure those two things. And over here, I'm going to add them up. All right, so you're going to see these two things changing on the left, but when you add them together, the two numbers are always going to add to 17.3. Right, so let's try. So let's take point E, start to drag it. And you can see right about there, that's the shortest distance you would ever get between point E and C. It's about 1.73. And it's the longest distance from B to E. That's 15.57. That's over here. So those, I click on both of those. Watch those two things I just clicked on as I continue to drag point E. Okay, they change. But when you add the two numbers together, in this case they're 6.65 and 10.65, you will always get 17.3 when you add them up. In this size ellipse, 17.3 is just this particular one. But the point is they always add up to the same thing for a given ellipse. Any questions on that idea? And that's how you would draw an ellipse. If points B and C, pretend like it was like a piece of wood or something, and you put in two nails at points B and C, and then you took a loop of string, put it around the nails and pulled it tight and drew, you would draw that exact ellipse. Whereas if you wanted to do a circle, all you need is like a piece of wood, put a nail in the middle, put a loop on it, pull it tight, and then just draw. So a circle just has a center. An ellipse has two special points when you want to draw it. And those two special points are called the foci. So a parabola has focus. An ellipse has foci, plural. This is basically summarizing, bless you. It's summarizing what we just said, but in a shorter way. If you measure the distance between a point and the first focus, and then measure the distance between that same point and the second focus, if you add the two distances together, it will always come out to a constant. In my ellipse, I think it was 17.3, something like that. These other terms, we're going to start to fill them in as we go, so you really don't If you want to draw this picture, you can, but you really don't need to label anything else at the moment, other than F1 and F2. Those are called the foci. P is just a point that I can drag anywhere I want on the ellipse. Right, so there's a few different terms here we're gonna talk about. And the first one is what's called the focal axis. The focal axis is the name of the entire axis that runs through the foci. So in my case, that particular axis is horizontal. I think I'm going to mention major axis in a minute. Yeah. So focal, I didn't want to put too much in the picture because it starts to look confusing. But focal axis is this whole line that goes on forever. I don't really refer to the focal axis that much. What I do talk about more is what's called the major axis. The major axis is a small section of the focal axis. Specifically, from here to there. What I just traced in red, that's called the major axis. It's a section of the focal axis that's basically inside the ellipse. I guess you could say it that way. It's the section of the focal axis inside the ellipse, where the focal axis goes on forever. Now, if you find, there's a couple ways you can word this. If you find the midpoint of the foci, or you find the midpoint of the major axis, however you want to word it, you get this point right here. That's the center. Okay, that's called the center of the ellipse. And I worded it as the midpoint of the segment that joins the foci. But it's also the midpoint of the major axis. Right? That's called the center. In all the examples we do to start, the center will be at the origin. We'll do a couple at the end where we shift the center away from the origin. So the major axis is the part of the focal axis that goes through the ellipse the long way. The minor axis is the part of the axis that goes through the ellipse the short way. So I go back up. This is technically the minor axis. It's basically the width of the ellipse. The minor axis and major axis are always perpendicular to each other, and they both go through the center. Now, you're never going to have to worry about the case with an ellipse on an angle. There's only two cases for an ellipse. You're either going to have a case where the ellipse has its major axis horizontal, or you'll have a case, bless you, or the case where the major axis is vertical. But it's never going to be at an angle. Okay, let me go back up to the picture for a second because I already labeled something that I think will give the next thing away. Where the major axis intersects the ellipse, I labeled it V1 and V2. Anyone have a guess what the V stands for? It's a term we studied when we did parabolas, and it comes up here again. Yep. It's a vertex. Except in an ellipse, there's two of them, so we call them vertices. V1, V2. So the points of intersection where the major axis hits the ellipse, those are called your vertices. Another way you could say it is the vertices are the endpoints of the major axis. Thank you. And that covers most of the vocabulary, but I know there's a lot there. Major axis, minor axis, focal axis, foci, vertices, center. Any questions on any of those terms? Most of those are going to be things we have to describe when you're asked to do something like this. Discuss. So when they want you to discuss an ellipse, you're going to want to describe where are the foci, where are the vertices, which way does the major axis go, horizontal or vertical, and the center. Where is the center? All right, let's look at the equation of an ellipse. So as I said, there's two cases. This is going to be the case where the ellipse is horizontal. So it's going to look more like this. The center will be at the origin. So that simplifies it a little bit. When it's not at the origin, we've got to put something else in. But for now, it'll be at the origin. And there's three letters that are going to be very important. A, B, and C. And I'm going to tell you what each letter means. C tells you the coordinates of the foci. In other words, this is your ellipse. And there's your center. You're going to have a focus here, and you'll have another focus here. So if those are the coordinates of the foci, what's this distance that I just traced right there? How long is that green line segment? Yep.
C units. Long.
Yep. C units. So this would be C units. And how about if I drew this line segment right here? How long would that one be?
Still C.
That's also C. So the distance between the foci is 2C. But C is the distance from the center to the focus. That's important to remember. So C is the distance from center to the focus. The major axis here runs horizontal. Think of the major axis. It goes along the x-axis. If the ellipse was vertical, then the major axis would go up and down. Okay, it would go along the y-axis. Now, the vertices, let me put those in. There's a vertex. There's a vertex. Now I'm going to ask the same question about these that I just did about C. Here's the coordinates of your vertices. Negative A0, positive A0. So what would be that dotted distance from the center to B2? A. That's A from here to here. And it's also A from here to here. So what does that mean? A is the distance from the center to the vertex. A is the distance from the center to the vertex. I didn't tell you what B is yet. I'll tell you that in a second. And there's your equation. So a couple things to always notice here. It's equal to 1 on the right-hand side. It's always going to be equal to 1. Whether the ellipse is horizontal or whether the ellipse is vertical, it's always going to be equal to 1. Another thing in this formula is the A value is always bigger than the B value. Always. A is always bigger than B, and they're both always bigger than 0. So A and B are never negative numbers. And a lot of times, out of the 3 letters, the A, the B, and the C, you're only going to know 2 of them. There's a formula you can use that connects them, and as long as you know 2, you can solve for the third one. And that formula is C squared equals A squared minus B squared. So C squared equals A squared minus B squared. Now, this is the example where the major axis is horizontal. I want to pull up where the major axis is vertical, and I just want you to compare the two and tell me what looks different. So everyone have this. You don't have to write it here. I just want you to look at it quick. What's different? Yep.
The A and B are flipped in the equation.
Right. These are the only 2 things that can switch places today. The first numerator is always x squared. The second one is always y squared. It's always equal to 1. A is always bigger than B, and this formula is always true. The difference in switching the A and the B controls which way the ellipse goes. A is always the bigger number. If you put A under y, that causes the ellipse to look like this. If you put the bigger number under x, that causes the ellipse to go in the x direction. So where you put the bigger number controls the direction of the ellipse. It's either going to be under x or it's going to be under y. Don't worry about that. That's not important. So some of this we already wrote down. So I told you A is the distance from the center to the vertex. I told you C is the distance from the center to the focus. That's going to be the last one I give you. Down there somewhere. There's C. But what's B? B is this. B is the distance from here to there, and from here to there. So B is what we call the distance from the center to the minor axis. So B is the distance from the center to the minor axis. A and C are probably more important when we're describing an ellipse because they tell us how to find the vertices and the foci. B, not as important unless you're making a sketch. If you want to make a sketch, then yeah, B is pretty important because it tells you how wide to make the ellipse, and A tells you how long to make the ellipse. So, if that's my ellipse, and the distance from here to here is B, what's the width of my ellipse? I can put these in two, like this. That's B. Yep.
2B.
2B. The width of the ellipse is 2B, and the length of the ellipse is 2A. That might come in handy for something. that's A, B, and C. Now, a couple different kinds of questions that I can give you. One of the type will be, I give you an equation, and then you tell me all about the ellipse. Another one is, I'll tell you about the ellipse, and you figure out the equation. And then the third type usually involves some kind of sketch. Let's look at the first type. This one is asking you to find an equation. So let's set up everything we can first, and then we'll figure out what we need to. What is the equation of an ellipse always equal to? What number did I say you should always put on the right? Yep.
1.
Yep, I'm always going to put a 1. And now on the left, you have two fractions. Are you adding them or are you subtracting them? Yeah? Adding them for today. Tomorrow, we subtract. Okay, don't want to confuse that. So today we're adding. What always goes in the first numerator? Yeah?
X. X squared.
X squared. And what goes in the second numerator? Yeah?
Y squared.
Y squared. Now that's assuming you don't shift it from the origin. If you shift it, you might see a plus or a minus next to the x if you went left or right, or a plus or a minus next to the y if you went up or down. Okay, but we're not shifting it right now. So the center is 0, 0. And now we have to figure out the two denominators. That's my a squared and my b squared. Well, first thing we want to do is figure out a and b, and probably c. So let's write those three things down. Our final answer when we're done will be in that box. Can someone remind me again, what is a? It's the, yep.
Distance from center to the vertex.
All right, I've got both of those, center to vertex. What's the distance between these two? Center and vertex. Yep.
4.
Okay, so we've got A. Now, we only have enough information here to find one of these other numbers directly, or one of these other letters. What's the other letter I can find? Yep,
C.
I can find C. I really need B, but I can't find it yet. C is the distance from the center to the focus. What's the distance from the center to the focus, Chris?
3.
3. Now, you might say, well, B is center to minor axis. We don't know that. You're right, we don't. But there is a formula we can use to find B. What's the formula that connects A, B, and C? It looks kind of like another formula we know, but it's not that formula. Jake?
C squared equals A squared minus B squared.
Yep. So C squared equals A squared minus B squared. Now, technically we don't need B. We need B squared, because that's what's going to go in one of these denominators. But we can solve it. So if we minus the 16, 9 minus 16 is going to give me how much? Yep.
-7.
So -7 equals negative b squared. Cancel the negatives. And b squared equals 7. So b is the square root of 7. Any question on that? Now we have to figure out where a squared is going to go and where the b squared is going to go. Remember, you want to put the bigger number under the direction you want the major axis to go. So do you want the ellipse like this, or do you want the ellipse like that? Which way do you want it to go? Well, the easy way to tell is graph these points. Just quick sketch. the major axis is always going to go right through all these points. So here's your center. You've got a focus at 3, 0, which means you also have a focus where? Yep. They didn't say that, but you have to. You've got a vertex at negative 4, 0, and that means you have a vertex at positive 4, 0. So for the major axis to go through all those points, do you want it to be horizontal or vertical? Yeah.
Horizontal.
You want it to be horizontal, which means if you want it horizontal, put the bigger number under the x. So that means a squared will go here, b squared will go there. A squared is 16. B squared, well, how much is b squared? Yep, 7. And that's the equation of your ellipse. Switch the 16 and the 7, and then your ellipse will be vertical instead of horizontal. That's the idea. Any questions on any of the choices we made or the numbers that we got in this problem? All right, so now the next one, I'm going to give you the equation. So you'll start with that, and I want you to discuss it. So remember, discuss means you basically have to find 4 things. What are the vertices? What are the foci? Which way does the major axis go? And where's the center? Those are the 4 things I want to know. Whether you're doing a problem like this one or the last one, find A, B, and C first. That's what you always want to do. So let's start with A. What's A in this case? Jack? 5. It's the square root of the bigger denominator. How about B? Yep. 3. It's the square root of the smaller denominator. Now C is the distance from the center to the focus. We don't know the focus. So how am I going to get C? Well, how can we get C? And we know A and B. So, yep.
A squared minus B squared.
Yeah, we're just going to use that formula. C squared equals A squared minus B squared. Exactly. So C squared equals A squared minus B squared. So what does C come out to? Yeah, 4. Okay, so let's start writing some things down. The center. When there's no minus or plus next to the x or next to the y, where does that mean your center is? Yep.
0,
0,
0.
0. When you see a minus, like if you saw something like this in one of the numerators, then you know your center has been shifted 3 units. But there's no numbers in the numerator. That means the center is 0, 0. Okay, so we got that. Major axis. I want to know if it's horizontal or vertical. Those are your 2 choices. Which way does the major axis go?
Horizontal.
How do you know that?
Because the bigger number is under the x.
Right. The bigger number is under the x, so that means the major axis goes in the x direction. So major axis is horizontal. What else? We want to find the vertices. What letter tells you how far away the vertices are from the center? Yeah. A. In this case, what's A? 5. So are my vertices 5 units left and right of the center, or 5 units above and below?
Left and right.
Left and right. They're horizontal. So here's the center. What's the coordinate that is 5 units left of center? Yeah.
Negative 5, 0.
Negative 5, 0. And what's the coordinate 5 units right of center? Oh, Ethan?
5, 0.
5, 0. When the vertex is at the origin, you're going to be able to use this symbol because there's going to be symmetry. However, whatever the first one is to the left, the second one is the same but to the right. So there's my vertices. And the last thing I'd want to know is the foci. What letter tells us something about the foci?
C.
C. So C tells us that the foci are 4 units away. And Bailey, can you explain like which way 4 units? Like 4 units above and below, or left and right? It's left and right again. Everything is horizontal in this problem. Can you tell me what 4 units left of center would be?
Negative 4, 0,
And 4 units right of center?
4, 0.
4, 0. And those are all the important things that they would ask you to describe from an equation. Any questions on how we got any of them? Yeah.
Actually, the center.
The center, well, as long as you don't have any addition or subtraction in the numerator, it's always 0, 0. Here's one that's not 0, 0. That's an ellipse, because it fits the pattern, but because of this -3 and -1, it's been shifted. When you don't have these two numbers, it's always going to be at the origin. That's at the origin. Any other questions on those? Right, let's look at the other equation, which I kind of already showed you quickly. But now A and C are still going to be the same. A is going to be center to vertex. C is going to be center to focus. But now it's going to be above and below. It's not going to be left and right. Center will still be at the origin. The foci will be C units up and down. The bigger number is going to be under the Y. So this is going to cause the ellipse to be vertical. The vertices are going to be A units above and A units below the center. And there's your equation. Right? And as we already looked at, the A and the B switch places. So A is still bigger than B. That's always going to be true. And C squared still equals A squared minus B squared. All right, so we'll try a couple where the bigger number is under the Y, but it's really very, very similar. And then we'll do 1 or 2 where we shift the center. And then that'll be it. first thing they want us to do is discuss this one. What's wrong with that? That's not ready to discuss. Yep.
There's no a squared or b squared.
Okay, so yeah, there's no a squared or b squared. What else is wrong with that? Yeah.
Equals 9.
That equals 9. It can't equal 9. And if we solve that problem, we'll solve that other problem at the same time. How can we, well, what is it supposed to equal? Yeah.
It's supposed to equal 1.
It's supposed to equal 1. So what could we divide everything by to make it 1? Yep.
9.
9. Divide everything by 9. Now it equals 1. So that's what we wanted. And we're going to have denominators on the other side. 9 divided by 9 cancels out, but you might as well leave something there because you have to recognize a squared and b squared. Okay, now that's ready to discuss. The first two things you always want to write down are the center and the direction of the major axis, because everything is built off those two things. Okay, what's my center in this one? Yeah.
0,
0,
0.
0. So you start seeing pluses and minuses next to the x and the y. The center is 0, 0. How about the major axis? Which way does the major axis go? Yeah.
Vertical.
Vertical. And how do you know it's vertical?
Because the 9 is greater than 1.
Yeah, the bigger number, which is the a value, or a squared technically, the bigger number is under the y. Now, this tells you that everything is vertical. Everything is above and below the center. That's important. How many units above and below the center? Well, actually, before we even do that, let's write down what A, B, and C are. I think right now that's all we can really do without A, B, and C. You can do that. But what's A? Yep.
3.
Yep, square root of the bigger number. A is 3. What about B?
1.
1, square root of the smaller number. Unfortunately, I really don't need 1. I need C, but I can't get C without it. So let's find C squared equals A squared minus B squared. So C is the square root of 8. And what does the square root of 8 simplify to if we reduce that? Tyler?
2 square root of 4.
Well, you would start out by writing it as the square root of 4 times the square root of 2. So that's one way to do it. And then you could simplify that.
2 square root of 2.
2 square roots of 2. Okay. So how far away are my vertices from my center? Yeah.
3.
3. 3 units, which way?
Vertical.
Vertical, above and below. So can you tell me what the coordinate 3 units above and below that would be?
0, -3, and then 0, 3.
Yep. And again, since it's at the origin and we have that symmetry, I'm going to use the plus or minus. Just saves a little bit of writing. And how about Casey? Can you tell me my coordinates for my foci? how far away are the foci from the center? Yep, 2√2. The foci are 2√2 units away from the center. And we just have to make sure that they are in a vertical orientation, not horizontal. So can you tell me what the coordinate would be for my foci?
0, 2.
And what about the other one? So 0 plus or minus 2 square roots of 2. Those are your foci. Okay, any question on that one? Alright, so let's try one again where we find the equation. Okay, again, first thing you want to do is write down A, B, and C. Abigail, can you tell me any one of those that you think you have enough information to figure out?
A would be 3 and
Yeah.
B would be 2.
So A would be 3, because that's the distance from the center to the vertex. And what other one did you tell me?
B is 2. Sorry, C.
So B is the distance from the center to the minor axis. The only way you're going to know B right off the top is if you have an image or a sketch to look at.
So C is 2, right?
Yeah, so C is 2, because that's the distance from the center to the focus. Unfortunately, to write the equation, you don't need C. You need B. But you're not going to get B without it, so you got to use it. How about Zach? What's my equation that connects A, B, and C?
I'm not sure.
You want to help him out? What's that equation that connects those three? Again, it looks kind of like another formula, but it's a little different. Yep.
C squared equals A squared minus B squared.
Yep. C squared equals A squared minus B squared. When you know two letters and you have to find the third one, that's the only way you're going to be able to do it. Now fill it in. 4 equals 9 minus B squared. Okay, so what does B squared equal? Yeah, 5. I really don't need B because I need B squared in the formula, so we might as well just leave it as 5. All right, let's set up our equation. All right, equation for an ellipse. It's always going to equal what number? Yep,
Well,
it's going to equal 1. What's going to go on the left-hand side? Just in general, you don't have to fill in anything specific. Just tell me kind of the general things you can always play. Yep.
X squared over A squared.
So x squared over something.
Yeah.
Yep.
And then plus Y squared over something.
You can always set all that up. Now we have to decide which way we want the ellipse to go. Graph these points and see how they line up. Do they line up horizontal or do they line up vertical? Well, you don't even need to graph all of them. Just graph 2 of them. Graph the vertices. 0, 3, 0, negative 3. Just from the vertices, I can tell which way these line up. They line up vertical. Which means, what do you want Well, yeah, let's do the y squared. What do you want to put under the y squared? Yep.
9.
Yes. A squared and b squared are going to be in these two spots. In this case, we want the a squared right there. And we want the b squared right there. And there's your equation. Any questions on how we got that equation? All right, so let's look at an example where we shift it. But if you understand when we don't shift it, then when we do, it's not going to be any harder. Not really worried about that. Okay, so that last slide, I skipped it, but it basically said that a circle is just a special case of an ellipse. If the major and the minor axis are the same length, then you get a circle. If one's longer than the other, you get an ellipse. But it's not super important. This is important. Two other letters in the mix now, H and K. What the H and the K are the coordinates of the center. Okay, coordinates of the center. So let me show you what the equations are going to look like now when we shift it. And I'll do the horizontal first, and then I'll do the vertical. All that's going to happen is this. Everywhere that you had an x in the old formula, you're going to replace it with this. X minus h. And what that minus h is going to do is account for shifting it left or right. Anywhere you had a y in the old formula, you're going to replace it with a y minus k. Everything else is exactly the same. Just make those two changes. That's it. So it's still equal to 1. Still have a plus sign. When the major axis is horizontal, we want to put the bigger number under the x. The smaller number goes under the y. But these are the two new things. Minus h, minus k. As always, a is bigger than b, and c squared still equals a squared minus b squared. None of that changed. What I circled in red is what's new. And the reason we never needed it before is because the h and the k were 0, 0. So if you minus 0, you might as well just get rid of it. And if you have a minus 0 because you haven't shifted it, you can get rid of it. And that's why I gave you the formula the way I did before. Just x squared and y squared. Well, now you've got a minus h and a minus k. And when the major axis is vertical, same thing. Just switch those two. And there's your other formula. X minus h squared, y minus k squared, and a and the b switched. So we'll try one of those, and then that'll be it. Just remember, H, comma, K. It's like alphabetical order. H comes before K. H is your horizontal shift. K is the vertical. All right, so let's find the equation of this ellipse. Again, whether you're finding the equation or whether I give you the equation, the first thing to always do is make this table. write down your A, your B, and your C, and now your H and your K. 4 out of 5 of these numbers should be real quick to find. Can anyone tell me any one of those numbers that they think they can get from this information? Yeah.
C.
Okay, what's C?
1.
C is 1. C is the distance between the center and the focus. If you can't see it, then sketch it. Here's your center. Right 2, down 3. Your focus is right 3, down 3. The distance between the center and the focus is 1 unit. Yep. Okay, what's something else that we can write down? Yep. What's A?
3.
How'd you get that?
Between the center and the vertex, y minus 2.
Yep, exactly. Your vertex is over 5, down 3. What's the difference? What's the distance between the center and the vertex? 1, 2, 3. So A is 3. Okay. What else can I write down? Yeah.
H and K.
Yeah, what's H?
2.
That's H. And what's K?
-3.
It's K. That's the only extra step. There's your H and your K. Now, let's find B, just like we always do. H and K have no effect on B at all, so you don't have to even worry about it. So C squared equals A squared minus B squared. Now, what's C squared in this case? 1. And A squared?
9.
9. So Eli, what's B squared?
-8. Or negative square root of negative. Wait, Z squared?
Yeah,
8.
just 8. You don't really have to find B. I mean, if you want to, you could, but B squared is what you need. So any questions on how we got that? If we want to put this is the square root of 8. Again, that's not a number I'm going to use. I need to square that in the equation. Okay, set up the equation. Okay, what's it always equal to? Yep, 1. Now on this side we have 2 fractions. What symbol always goes between them? Francesca? Plus. Now remember, your numerator is usually x squared here and y squared there. But because we shifted it, we have to do minus h and minus k. So what's going to go right here after the minus sign would be x. Is that? Yep, so you're going to have x minus 2. You're going to be a little careful. What's going to happen inside here? Y minus k. Have we go?
It's gonna be y plus.
It's going to become y plus 3. So that's something you have to think about if they ask you to work backwards from the equation and find the center. You have to remember that it's 2 negative 3. That's what this was. Okay, so we got that. Now we need to figure out where the a squared and the b squared are going to go. I thought I sketched guess not. Didn't I sketch all these points somewhere? Did I erase it? I must have erased it. Well, does anybody remember how the points lined up? Were they vertical or horizontal? They were horizontal. Right 5 down 3, right 3 down 3. They're all down 3. So they're all going to be horizontal. So where does that mean we want the bigger number? Under X or under Y? Yep.
Under X.
We want the bigger number under X. That means you want A squared under the X. What's going to go under the Y? Yep. What is it?
Square root of 8.
B squared goes here.
8.
8. And that's your equation. Okay, so it's not too bad, but it's when we learn tomorrow, it's almost identical to this, except everything that was a plus becomes a minus, and minus becomes a plus. So then it starts to get tricky to remember. But until you learn that, I think it's not too bad. Yes. So those are all odd for the homework tonight. And just odds.